Now let's explore another component of this trading system. And this time we're going to explore the performance tracker module. So the performance tracker module has this class uh, performance tracker. The purpose of this module is to track the performance of various key operations which are performed or executed by this trading system. So the various public methods that we have in this class are a constructor and the constructor, and this constructor is declared explicit for the reason that it prevents the implicit conversions from string to performance tracker. So we can have more control over which operations to track for performance. So it will provide any accidental tracking of an unintended operation. Then we also have a destructor and a function to get the elapsed time, or the time taken by the operation that was being tracked. Then exploring the private members of this class, we have a string action, and this is basically the name of the operation being tracked. Then we have another data member, start time. The data type of this is a high resolution clock time point. So basically it represents a time point of this high resolution clock, which is defined in the chrono library. So the specialty of this high resolution clock is that it has the highest resolution. It provides the highest resolution which the system is capable of. So usually this can measure time up to the granularity of nanoseconds. So we have another data type of this, another variable of the same data type, which is the end time. And we will see how they are used to measure the operation of the how to measure the performance of the given operation. Then we have another variable which ensures that which signifies if the clock is still running or the clock has been stopped. Then let's take a look at the implementation of this class. So first we have a constructor, and it has a single parameter which is a reference of type string, and which takes the which basically refers to the name of the operation we are going to track. And then we are basically setting or assigning this action argument to the action data member of this class. Then we are measuring the start time. So the start time is measured the moment the class is instantiated or created. So the start time is so we are measuring the current time on this high resolution clock. And this stopped variable is set to false, means that the operation is still running. So the destructor checks if the operation that we are tracking is still executing. If it is still executing, so this performance tracker object is about to get destroyed. So it's going to record the end time, which will be the current time on this high resolution clock that the system provides, or this chrono library provides. So we are going to measure the current time on this high resolution clock and assign and store this inside this end time variable, which is a private data member. Then we are going to set this stopper equal to true, meaning that the execution of the operation which this object is tracking has stopped. Then at last we have the implementation of this get elapsed time method, which basically gives the time taken by the operation that this object that we were, or the object was tracking. So the first thing does it checks if the stopped variable is true or false. If it's true, which means that the operation has already stopped, and we must have the end time inside this end time variable. So we are going to assign this into this now variable. Otherwise, if the operation was still running and we have to calculate the elapsed time up to the point of this function is called, we are going to record the current time on this high resolution clock. Once we have the current time on this high resolution clock, one way or the other way, we are going to calculate the difference between these two variables, which is the end time and the start time. Now this difference is stored inside this elapsed variable, which has a type duration of double precision. Since we are dealing with a very precise clock here, which can measure time up to nanoseconds, so we must use a suitable data type so that we don't lose precision. So we are using this double variable. Then what we are doing is we are declaring an output stream buffer. Once we have this output stream buffer, we are going to set the precision of that is the number of digits that will be printed after the decimal point to 6. To store the time as precisely as possible. Then we are going to count this elapsed dot count. This is a function call, and this count method is inside this elapsed object, and it basically gives the number of seconds in this time duration. Once we have this elapsed time formatted inside this string buffer stream, we are going to convert this into string and return to the calling object. Since we have explored the implementation details of the performance tracker class, it's time that we write a test file to test the functionality of this class. Now, so here we have a test file, and I'm going to explain this code. The first thing is just a test statement on the console, and the second thing is that we are making a function call to this simulated operation method. So let's take a look what is inside this method. So it has no return type and it takes no parameters. So what it does is basically it creates an instance of this performance tracker class, and it passes the message, the simulated operation, which means we are tracking, which means the operation that we are tracking. So then what we are doing is that we are putting this thread, the current thread, to sleep for 2 seconds. So remember that this trading system does not leverage the capabilities of multi-threading in C++. That is beyond the scope of this trading system as of now. But in order to demonstrate the capabilities of this performance tracker class, we need to explore this threading library, or we need some help from this threading library. So we are putting the current thread to sleep for the given time, chrono seconds. which means this is an object inside the chrono library, which is used to represent the seconds duration. So once we have this thread for sleep, after instantiating the performance tracker class, then after this thread comes back from sleep, we are going to execute this line of code will be executed, and it's going to print the elapsed time on the screen. So after this, the control comes back from the simulated operation method. We are going to do another test by creating another instance of this performance tracker class, and this time we are putting the thread to sleep for 500 milliseconds, and we are using the according object from the chrono library for that. Once the control reaches this statement, it's going to print the elapsed time. Remember, the clock is measured, or the time measurement begins the moment the performance tracker class is instantiated. So after that, we have some this exception handling code. We have seen it multiple times. Now let us see this in action. So for that, I'm going to navigate into my command prompt, where I have already built this, and we're going to run this performance tracker executable, performance underscore tracker, enter. So it's so the test is successful. So the latency of the first operation, the simulated operation, is 2 seconds, and the latency of the second operation is 0.66 seconds. Remember that we put the first time we put the current thread to sleep for 2 seconds, and second time we put it to sleep for 500 milliseconds.